This lab, determining the KSP, solubility product constant of calcium hydroxide, is one that's going to be performed using microscale techniques. This involves titration of the saturated solution of calcium hydroxide with a 1/10 molar solution of hydrochloric acid, and we go from a solution that is basic to one that is acidic, and the indicator is going to be phenolphthalein. Atypical of these types of titrations, we're going to start with a solution that has the pink color of phenolphthalein and titrate to a colorless solution. For this titration of calcium hydroxide with 1/10 molar hydrochloric acid using phenolphthalein endpoint, I've already filled up my 3 pipettes. I have a saturated solution of calcium hydroxide, I have a solution of 10th molar hydrochloric acid, and I have a solution of phenolphthalein, my acid-base indicator. I'm going to use a white background for this titration because I can more easily see a change from a dark color to a light color using a white background than I can with the dark background. That's up to the individual. First, I'm going to add 50 drops of calcium hydroxide solution to each of 3 different well holes. I'll then add a drop or 2 of the phenolphthalein indicator to each of the 3 well holes, and then titrate with the HCl to an endpoint that goes from pink to colorless. To ensure that I have uniform size drops, I'm using this microwell burette stand, if you will, pipette stand, and that assures that my pipette is held vertically, and that also assures that the drops are fairly uniform. I'm going to proceed to add my 50 drops of the calcium hydroxide. Having added my 50 drops of calcium hydroxide to one of the 3 well holes, I do the same thing with the others. I'm now going to add a drop or 2 of the phenolphthalein indicator. You notice the pink color that's formed. Now going to take my hydrochloric acid, place it on the pipette holder. I can slide that down so that the tip of the HCl is a bit closer to the solution containing the calcium hydroxide. And now I'm going to titrate with the HCl, counting drops as I go. Now, having done this before, I know approximately how many drops this is going to take, but somebody who has not done this before would not know that. So the first titration is going to be fairly slow. Notice the colors starting to change. Now, I did not add 50 drops in this for this video, but if I had, it would have required more. So the titration would have required more of the HCl. So notice that my solution now is colorless, which is an indication that I've reached my endpoint. And I'm going to stop my titration and do my calculations. Keep in mind that it's probably best to do 3 titrations, see if the results are in agreement. If they are, then I don't need to do another, but if they're significantly far off, whatever significantly is, based upon your teacher's evaluation of significant, you probably want to do another titration. To clean everything up, I just take this over to a sink with running water and shake this solution into the sink. and then rinse the well holes with distilled water and then shake dry and air dry for the next time. All that's left then are the calculations.